I want to start out by reviewing just a little bit. I'm spending a lot more time on finite state Markov chains than we usually do in this course, partly because I've rewritten this section, partly because I think the material is very important. It's sort of bread and butter stuff of discrete stochastic processes. You use it all the time. It's a foundation for almost everything else. After thinking about it for a long time, it really isn't all that complicated. I used to think that all these details of finding eigenvalues and eigenvectors and so on was extremely tedious. And it turns out that there's a very nice, pleasant theory there. You can find all of these things after you know what you're doing by very simple computer packages, but they don't help if you don't know what's going on. So here we're trying to figure out what's going on. So let's start out by reviewing what we know about ergodic unit chains and then proceed from there. An ergodic finite state Markov chain has transition probabilities which if you look at the transition matrix raised to the nth power, what that gives you is the transition probabilities of an n-step Markov chain. In other words, you start at time 0, and at time n, you look at what state you're in. P sub I j to the nth power is then the probability that you're in state j at time n, given that you're in state I at time 0. So this has all the information that you want about what happens to the Markov chain as time gets large. One of the things we're most concerned with is, do you go to steady state? And if you do go to steady state, how fast do you go to steady state? And of course, this matrix tells you the whole story there, because if you go to steady state and the Markov chain forgets where it started, then P sub I j P sub I j to the n goes to some constant pi sub j, which is independent of the starting state I and independent of n asymptotically as n gets big. So this pi is a strictly positive probability vector. I shouldn't say so it is. That's something that was shown last time. If you multiply both sides of this equation by P sub jk, multiply this by P sub jk,